Hello everyone, today we are going to solve GFG problem of the day, balancing consonants and vowels ratio. So let's see what the problem says. And before we move ahead to its discussion, I hope you already know what are vowels and consonants. If you don't know, vowels are nothing but A, E, I, O, U, and rest of the things in A to Z are consonants. So we have been given an array of all small from A to Z, and it will be a array of string, but it will have A to Z in small. And in this, what we can do is we can concatenate the contiguous part of this. And after concatenating also, if we find anywhere where vowel and consonants are equal in number in that substring, like suppose AB we concatenated with EI. So in this, if vowel and consonants are equal, so it is a valid answer. So we need to count all those valid answers in which vowel and consonants are balanced. So let's see what are the valid answers here. So if you see AB, in this vowel and consonants are balanced. So this is a one valid answer. Now this EI, two vowels are there, so it is not a valid answer. But this EI, if you concatenate it with CD, EI, CD, two vowels, two consonants, so it is a valid answer. Now CD and OU. CD, OU after concatenating two vowels, two consonants. This is also a valid answer. And there is one more valid answer. AB, EI, CD together concatenated. AB, EI, CD. So A, E, I, three vowels, B, C, D, three consonants. It's also balanced. So this is all the answer. So these are all the answers. So how many we find? We found four. So four we can return. If we return four, it will work and it will say yes, the answer is right. So this is what we have to do in the problem. Let's move ahead to its first brute force approach. So the brute force approach is nothing. Find all the arrays, find all the sub arrays, and then keep count like how many vowels and consonants are there. If they are balanced, like equal number of vowels and consonants are there in the sub array, that is a possible answer. So first we will consider A, B, E, A, B, E, I, A, B, I, C, D, A, B, I, C, D, O, U together. These are all the sub arrays starting from A, B, then E, I, E, I, C, D, E, I, C, D, O, U. This, then C, D, C, D, O, U, and then O, U. So this is like you can find all the sub arrays and do find if it is balanced or not. We will not be taking brute force approach. Let's try to find some optimal solution for this. So if you see here in AB, there is one vowel and one consonant, right? So can I concatenate it with any letter that has two vowels? I would say no. I cannot concatenate it with any letter which has two vowels. So with which I can concatenate it. So if I have one vowel and one consonant, I can only concatenate it with word which have one vowel and one consonant. Why? Because we want to balance vowel and consonant. And if I concatenate it with two vowels, if I concatenate these, so number of vowels if after concatenating would be 3, number of consonant would be 1 after concatenating. So this will never be our working solution. What can I do is, if there is one vowel and one consonant, we can concatenate it with uh, only a string that has one vowel and one consonant. Okay. So if we are concatenating it with CO, A, B, CO, it is balanced and we can say we can concatenate it. So keeping this in mind, can I say that if let's see this CD, there is two consonant. So if there is two consonant, can I say that I can concatenate it with only those which has either two vowels, right? Because two consonant, to balance those consonant we need a vowel. So so what I can do is, if we can find in this one, let's say this AB, what we need. In this AB, we have one vowel, one consonant. It is balanced, so we don't need anything. So if I store 0 here, is it fine? So how we are storing 0? Let's say vowel we are storing +1, consonant we are storing -1. So AB +1 -1, that is nothing but 0. EI, two vowels. So if I store this EI, two vowels, can I say that +2? Because for vowel we are doing +1. So +2. CD, two consonant, -1, that would be -2. If I store this -2, is it um, okay? Now let's see OU. OU, two vowels +2. So now what is this +2 and -2 are denoting? So if you see this CD and it is denoting -2, what does this means is, it needs, like here, whatever it has two consonant, and -2 means it it needs +2, two vowels at least to balance it. It it is storing +2. What +2 means? So +2 means nothing, but it is having two extra vowels, EI. So whatever we will be storing, what we can do is we can store this, like whatever extra it has. So we are storing whatever extra it has. Let's say AB has 0. 0 means it is currently balanced. EI means it has extra vowels. So if it has extra vowels, we need to concatenate it with that part which has two extra consonants. So if we balance it, it will give us right answer. So now the problem is reduced to sub-array having sum 0, isn't it? Because if you see it, here, if we have stored +2, and what this +2 is denoting, it has two extra vowels, and if we can concatenate it with any letter that has two extra consonants, then it will it will be valid. So if we store like this, and what we can do is, if any sub array whose sum is 0, that would give us our answer. So if you see 0 plus 2 minus 2 till this part, this is a valid answer. And if you see, we have concatenated this, we have calculated it in our answer. So now the problem reduces to sub array sum equals 0. Phi equals 0. So if you see till this part, sum is 0. And how it is reducing to 0? Because if any point, what we are storing is what is extra. So here two extra vowels, here two extra consonant, -2 means two extra consonant. And if any point these vowels and consonant balances, that means is that is a possible answer where our vowels and consonants are becoming equal. So now the problem reduces to sub array sum equals k, like equals k. Here k is 0, and that is my previous video that I had uploaded. So if the problem is reduced to sub array sum equals k, what we can do is, nothing we need to do is, we already know, I hope you already know sub array sum equals k. If you not, please go and watch the video. If we can store this, like this balance, so in this string we have, if we can store this somewhere, now our problem is reduced to sub array sum equals 0, then we can easily find. Now till here the sum is 0. I can say, hey, earlier was some 0 anywhere? So it would say yes. At the starting, sum is always 0. So I would say my 0 is coming, and what was the zero's frequency? 1. So my answer would be increased by 1, and now at 0, 0 was already there. Now I will do 2. Now this plus 2 came. I will check in my answer, was there any time where we have um, 2 there. So in subarray sum equals k, what we were doing is sum minus k. But here our k is 0. So we are not doing sum minus k. And why we are doing is, let's suppose till this point my sum is x, and till this point my sum is also x. That means there was some point between them whose sum was 0. That in this case only it would be sum here x and here x. So that logic only we were following for subarray sum equals k. Then the same logic we are going to follow here. Now I hope you already know subarray sum equals k, but if not, I'm traversing. But if you want in detail, you can watch my previous video. Now we came to, we solve sum minus 0, nothing, that is only sum. My sum became plus 2 now. I will check, was there any point in where sum was 2? So I will not find, and 2 is coming first time, so I will store this. Now my sum was 2, right? Now sum was 2 minus 2, 0. Again sum becomes 0. I will check, was there any point where my sum was 0? So earlier 2 times my sum was 2. So I would add 2 in my answer, and in 0 I would store 3. Now my sum is 0. Okay. Now I'll move ahead. Sum till here, the sum was 0. 0 plus 2 is 2. So I will check in my array, was there any point I find 2? So I will check, yes, I find 2. So what was the frequency? 1. So I will add 1 in my answer, and 2's frequency 2 came again, so I will update it to 2. So this is what we were doing in subarray sum equals k, and whatever is our answer holding, that would be our answer. So this is the possible approach, but there is one more thing in the solution. One more optimization we can do is, so if you see, we are storing it in an array, but do we need to store it in an array? I would say no. Why no? Because instead of storing, what we are doing in this one, we are doing sum, right? Sum plus this, sum plus this, sum plus this, sum plus this. So if we can store, if we can calculate this some at some point and do it in sum, I don't need it anymore. So instead of using the sub array, instead of using the array, if in my sum I have its effect, I can say that it's I already have its effect. I don't need it anymore. Then again came to, I can add it in my sum, and my sum holds all the things. So I don't even need a sub array in this. I don't even need a array in this case. So I hope you got this optimization till this point. Now let's move ahead to code and let's code it up. So let's see. Video is already 14 minutes, so let me paste the code and I can explain it because the video is becoming too big, but let's see how it goes. So first thing, we have created a map. Why we created map? Because subarray sum equals k, we were also creating a map. And now our like prefix sum is now 0, answer we are storing now 0. And in at starting in the map we were putting 0 comma 1, because like at starting sum was 0 and it's occurring once, so we are storing in map 0 comma 1. Now in this string we will run a loop in this string, and in this a, like let's say we find aeio, so we will find if it is balanced or not, right? So our this function is vowel will tell us is it a vowel or not. So if it was a vowel, we are doing +1. If it is not a vowel, we are doing -1. And in the end, this current sum will store all the values, like it either it is what should be stored here, like +1 or -1. So let's say aeio. So here if you see, there is AB. A would contribute +1 and B is contribute -1, right? A is contributing +1 and B is contributing -1. So in our C sum was 0 initially, and A contributed +1, now C sum became 1, B contributed -1, it became -1, now C sum is 0. So that way we are storing in our current sum. So what is this current sum would be storing is, this current sum would be storing nothing but whatever we were storing in that array. So in that array we were storing, let's say aeio, no sorry, aeio c, aic. So there are three vowels and one consonant, so three vowels means +3, one consonant means -1. And here what we can store is 2, so that is getting stored nothing. For each and vowel we are doing +1, for each consonant we are doing -1, and we are storing here. So instead of storing, I as we discussed, we need it only once, like summing, doing it sum to our this sum, like adding it to our sum. So first we are calculating this current sum, and then we are adding it in our total sum. And now this is the part of logic where we were checking if it is in our map, then it is coming again. Like if it is in our map, that means there was some point in a map which value was x. So earlier it was x, now it is x. So between those points, there is definitely some point whose sum is 0. So that is our possible answer whose sum is 0. So we are adding it to our answer, whatever the number of times it has appeared, and then the main thing is adding that in our map, like whatever the sum we have got, adding it, we are adding it in our map. If it is not there, it will add 1. If it is already there, it will also add 1 to its frequency. And in that way, wherever we have found like some 0, it will be stored in our answer. So I hope you got the idea. Let me compile it. Sorry, let me submit it. So it is getting submitted. So I hope you got the idea. This was a implementation, like use case of subarray sum equals k, and it was a good problem. And if you see the time complexity, it is given O of n, but I would say it is not O of n. And if n is the length of the array and n into whatever, like the sum of n into this, whatever is the like length of these arrays. So it is not definitely O of n. It is O n into the length of these. So I hope you got the idea. And if you got the idea, please like the video. Until then, keep coding.